Let's talk about the storage options that we have available to us for high availability and business continuity. Starting with EBS volumes, they have an annual failure rate of less than 0.2%, and that's compared to normal commodity hard drives at 4%. So if we had 1,000 EBS volumes, we could still expect 2 of those to fail per year. They have an availability target of 99.999, and AWS achieves that by replicating the data automatically within an AZ. But watch out, because it does say single AZ, so that leaves us vulnerable to an AZ failure, so we should plan accordingly. Fortunately, it's easy to snapshot the data which is stored on S3, and that is multi-AZ durable. And you can copy snapshots to other regions as well if you want some safekeeping. EBS does support RAID configurations on the systems. And I'm going to go over the different levels of RAID because you might see questions on the exam about the different levels of RAID. But it's also important to understand the trade-offs and what each RAID level offers you. If we start with RAID 0, it offers us no redundancy. That just means we write data across multiple hard drives. And this is sometimes called striping. The good news is you get good reads and good writes because you're distributing the load across multiple I/O devices. So we can move up to RAID 1, and sometimes this is just called mirroring, because that's exactly what we're doing. We're taking 2 drives, and we're copying the identical data to either drive. In effect, though, that reduces our capacity by 50% because we have duplicate copies. And RAID 1 is a little bit slower on reads and writes than RAID 0. Now you'll see we're completely skipping over RAID 2, RAID 3, and RAID 4, but those aren't really used nowadays. We can go up to RAID 5, which is pretty popular, and you need a minimum of 3 drives for this. And that's because 2 drives will store the data, and then 1 drive will store a parity bit. And the parity bit just allows you to recover information if one of those drives is removed or fails. So we can add an empty drive, and RAID 5 can calculate what's missing and recreate that data. RAID 6 is a level above RAID 5 because it actually has 2 methods of parity. It has a primary parity method and a secondary parity method, and we can actually permit 2 drives to fail out of a RAID 6 array, but it requires a minimum of 4 drives. Now we also have nested RAID levels like RAID 0 plus 1, but we're not going to talk about those since they're really closely tied to the capabilities of your particular OS. Now, as far as AWS, they don't recommend using RAID 5 or RAID 6. The reason for this is because EBS volumes are accessed over a network. Writing those parity bits sucks up a lot of I/O. It can consume as much as 20 and 30% of your available IOPS. So if you want to do RAID on AWS, stick to RAID 0 or RAID 1. Speaking of IOPS, let's see how RAID levels impact our throughput and our IOPS. So if we just start with no RAID at all, we have a 1 terabyte volume. Let's say we provision it for 4,000 IOPS. We have a usable space of 1 terabyte, and we have throughput of 500 megabytes per second. Now if we implement striping, RAID 0, we can get 2 volumes of 500 gigabytes, and each one of those is provisioned at 4,000 IOPS. We then have a total IOP volume of 8,000. We still have the same usable space of 1 terabyte, but our throughput is doubled. And this is because we're spreading that load across multiple drives. Now, if we move to RAID 1, we have the same 500 gigabyte drives. We have the same provision IOPS, but because we're duplicating the data across both those, our usable space is cut in half, but our throughput remains the same. So S3 storage has many different options as far as storage classes. We have the standard storage class, which is 99.99 availability, which, as we learned in the concepts segment, is maybe not 100% guaranteed. We have a standard infrequent access, which is less than 9. That equates to 8.7 hours of year. Then we have one zone infrequent access, which is 1.8 days per year of unavailability. Now, unavailability does not mean that the data goes away. In fact, all the storage classes still have the 11 nines of durability. So that just means when you want to access the service, one zone infrequent access maybe is unavailable 1.5 days out of the year. Now, standard and standard infrequent access have multi-AZ durability. One zone only has single AZ durability. And as you already know, S3 is a backing service for EBS snapshots and many other AWS services. Now, Amazon EFS is an implementation of NFS. We've already talked about this in prior segments, but it's quite robust, and it's a good way to achieve multi-AZ redundancy for a file share. We can take a look at an example where we have an EFS volume, we have mount points in different AZs. If one of those AZs failed, we can just continue to scale out our web servers, and they would just point to that mount point that's available in whatever local AZ that they happen to come up in. Some other options, Amazon Storage Gateway is a good way to migrate on-prem data for offsite backups, and it can keep things in sync. Snowball, as we've already talked about, has various options for migrating data to AWS, but it's only suited for batch data transfers. And here's some ways how we might use those.